Okay, so I've gone over to a clean board for translation. So once the mRNA's been built, it's been spliced, it's got its 5' cap, its poly A tail, it's now going to leave the nucleus and it's going to go out and be found by a ribosome. And ribosomes are your translators. They're your little chefs that read the recipe and build the protein. Okay, and your ribosome, they are made out of both protein and ribosomal RNA. It's just pieces of RNA that are watered up in there, and they help it find the mRNA and all that. So if I were to draw a ribosome, it comes in two pieces, okay, and it's got 3 sites, my ribosome, and it's got the bottom piece, okay? And this is an E site, and a P site, and an A site. Okay, so when the ribosome comes in, or the mRNA comes in, here it goes, it comes in here, and the first thing that happens, the first thing that happens is it gets recognized in the A site. So here we go. Here's our mRNA. It's just sitting here in the A site. Okay? Now, in the A site, I have an AUG. So this is where it gets read. And the ribosome says, all right, what matches AUG? And it uses the codon table. Not really, but it uses the codon table. And its AUG stands for methionine. And so, we get what we call a transfer RNA, okay, a tRNA, and these transfer amino acids to the ribosome. So a transfer RNA will come in like that, and it's carrying a methionine, okay, and it comes into this site. Now, it's got to be able to recognize that AUG, and so, and let's see, is it on? Okay, so 8 asks them, what amino acid did your protein start with? Well, it should have started with a methionine. Tell them, if it did not start with a methionine, they messed up. Always. It always starts with a methionine, so it should be an AUG. So that's the first question. And the second question asks them, how did you know when to stop translating? We're going to get to a stop, and I'll show you in a minute. But it comes in here, it says AUG. All right, so it's got to be able to bind to that. So a transfer RNA is made out of RNA, and it will actually have the opposite code here, UAC. And that opposite code is called the anticodon. And the anticodon matches with the codon. It brings methionine. Then, give me a second to do my drawing, it clicks over one. All right, so we're going to take this methionine and we're going to move it over. All right, so our methionine comes over to here, click, click, click. UAC, carrying a methionine. Okay, and then the next codon in the sequence happens to be CAC. So they're going to go to their genetic code and say, okay, CAC codes for what? I have no idea. Let me look. CAC codes for a histidine. Okay, so then this one's going to come in. The next amino acid carrier, tRNA, is going to come in and it's carrying a histidine. Okay, and what's its anticodon? If this is CAC, then its anticodon is GUG. Now remember, the genetic code is written in codons, not anticodons. Genetic code is written in codons. So GUG comes in. So in the P site, P stands for polypeptide in my mind. All right, so in the P site, we're going to make a polypeptide, a peptide bond between the methionine and the histidine. And then the last click over is the exit site. This is where this guy, he will let go of his methionine, and the red guy will leave empty, the UAC one. He'll leave empty, and he'll go get another methionine, and then come back around if you need another methionine. All right? So just click, 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 click all the way through, and it gets translated from RNA sequence to amino acid sequence. Okay? And that's translation. And it asks, let's see, on number 9, it asks, okay, notice that we needed to pick up a bead and bring it to the ribosome to be added. What's doing that is the tRNA, so help them define tRNA. It asks, how many tRNAs do you think there are? Well, if we need a tRNA for each different codon, we need a different anticodon, then you would guess probably 64, actually 61, right? Because 3 of them are stop They don't code for anything. By the way, when it gets to the end, when it gets to a stop, nothing comes in and therefore the ribosome drops off. That's how it knows when to stop. Okay? So really 61 would be a good guess for how many tRNAs there are, because there's 61 codons that code for something. But remind them of wobble. So the wobble, because multiple codons code for the same thing, that third position often doesn't matter as much. And so there's actually in reality only 45 transfer RNAs because some of them will sit down on multiple codons. So just FYI. All right, it says, how does the ribosome know which tRNA to recruit? It's looking at the anticodon to match. What does the anticodon bind to? The codon. Okay, and is the anticodon the same sequence as the code of the template? This is a great question to let them struggle with. And the answer is the anticodon, these in red, should look just like the template. Because the code, or the mRNA always is identical to the code. Okay, so the anticodons are the template. All right? Okay, and I'm going to pause this before I do mutations, so I can erase my board.